Alright, well hello everybody. Here we are trying to solve this equation, trying to find the x values that make the equation true. And a few little tricks for this one that kind of help. The first one is, if we take a look here, we know we have an identity that looks like this. That's on the formula sheet. That's called the Pythagorean identity. And so if we want to solve for sine x on this thing, or I should say sine squared x, we have 1 minus cos squared x. So that just comes directly off the formula sheet. And that sine x, sine squared x, we can replace right here. So we can rewrite the whole thing as 2 times 1 minus cos squared x plus 3 cos x minus 3 equals 0. Alright, so that's the first step, and it doesn't look that great yet, but pretty soon it's going to look like a regular quadratic equation. So for example, if we distribute the 2 and keep everything else the same at this point, then what happens is we just combine like terms. We have negative 2 cos squared x plus 3 cos x and minus 1 equals 0. I'm going to multiply everything by negative 1 just because I don't like that negative sign there. So I have 2 cos squared x plus, oh sorry, no, now it's no longer plus. Now it's minus 3 cos x and plus 1 equals 0. Alright, well, what we have now, if you're not sure about this, what it actually looks like, think about it like this way. 2x squared minus 3x plus 1 equals 0. That's a quadratic equation. And so we can factor it. So what I'm going to do, I'm going to switch back to green again. And I'm not going to use x's. I'm going to use the actual cos x's. And we're going to have two brackets. One is 2 cos x plus or minus something. And the other one is cos x plus or minus something. Okay, so basically we're doing factoring right now. And so the question is, what numbers belong here and here? Well, I know that when I multiply those two numbers, I should get positive 1. So the only thing they can be is either positive 1 and positive 1, or they might also be negative 1 times negative 1. But I know that since I have a negative sign here, they're going to have to be negative. So it must be negative 1 and negative 1. And just to do a quick little double check, I'm going to erase this for a second. In case you're ever not sure, actually I would say even if you are sure, it's worth double checking. Let's just try that. Whoops. Let's just try to see if we actually got this correct or not. So I multiply the first term by the first term. I get 2 cos squared x. First term times last term, negative 2 cos x. And then negative cos x and plus 1. And indeed, 2 cos squared x minus 3 cos x plus 1. So I know I'm correct because this is the same as actually this right here. So I know it's correct, so that's good. Okay, so I'm just going to erase that since we've already confirmed in our minds that that is for sure. And now it comes down to the actual solving the equation. So let's go to blue now. So now we basically have, whoops. Sorry, we actually have two equations. We have this equation, which is 2 cos x minus 1 equals 0. And we also have this equation, cos x minus 1 equals 0. We know that one of these two must be equal to 0 because the result is equal to 0. Okay, so that means on this side we have 2 cos x equals 1, or in other words, cos x equals 1/2. And over here, we have cos x equals 1. So there's basically two equations we have to solve now. There's this guy. Oops, where's my pen? There it is. And this guy. Cos x equals 1/2, or cos x equals 1. I'll even put the word in there, or. Okay, so how do we think about solving these things? Well, I would suggest first of all starting with the unit circle. Let's look for places where cos x equals 1/2. Okay, I happen to have the unit circle right here. So I'm looking for cos x equals 1/2. There's a spot right there, because remember, this is the cosine of an angle, pi on 3. And we've got another situation like that way over here. 5 pi on 3. So 5 pi on 3 and pi on 3. Those are the two solutions within this unit circle that are solutions to that first part of the equation. So let's go back for a second then. So what that means is we have, I'll just start up here again, x equals pi on 3 and x equals 5 pi on 3. Okay, but it's not just those two, because here's pi on 3. In addition to pi on 3, we also have this angle all the way over to here, which is actually pi on 3 plus 2 pi. And we also have this one here, 1, 2, 3, all the way over. So that's, again, another angle, pi on 3 plus, and so basically we keep on multiplying, or adding, multiples of 2 pi. We keep adding 2 pi each time. So the way we write that is just by saying plus 2 pi n, and over here we say plus 2 pi n. And so that n variable is just, it's an integer. Okay, so that's all that just came from this equation here. Let me switch to another color. How about brown? So let's look at this guy. Well, now we're looking for where is cosine equal to 1. Here. Cosine is equal to 1 right there. So that's at the angle 0, or 2 pi, or actually another one there is 4 pi, or 6 pi. Every time we go around, it's 2 pi, 4 pi, 6 pi, 8 pi, 10 pi. We just keep going like that. And so what we have there is x equals 2 pi multiplied by n. So that essentially gives us all our solutions. And then if somebody else is reading this, we need to tell them what that n is, because we haven't really mentioned it. So let's just say n is an element of the integers. That just means n is an integer. Okay, so essentially that is the answer. And if we just want to take a quick look at what this looks like, I'll just do a really quick sketch just to make sure we're really clear on this. Here's the graph, and I'm going to make the graph of cosine. Cool. Okay, so up here is 1 on the cosine graph. So we have solution here. Actually, I'll use brown again. There's one solution, another solution, another solution. These are all the points where the cosine graph is equal to 1. And we've done that part here with the brown color. Then with the red color, we're looking at where is the cosine graph equal to 1/2, which is here. So we've got pi on 3 here, and then we've got pi on 3 plus 2 pi over here, and pi on 3 plus 2 pi plus 2 pi over there. So these red dots refer to, I'll just draw an arrow from here, like that. And then let me use one more color, black. The last one is this dot here, which is 5 pi on 3. I'll put here 5 pi on 3. And then we've got another dot here, 5 pi on 3. There would be another one back here somewhere, 5 pi on 3. And all these black dots come from this part of the solution. So we can see graphically what it looks like as well. And yeah, basically that's a long-winded solution. But if you don't understand it, feel free to go back, rewind, re-listen, try again. And if you're ready, then it's time for you to try your own. So check out the homework questions, and good luck.